Alright, day 14, hyperbolas. So what I'm going to do is I'm going to show you how to graph a hyperbola. And I'm going to talk about the characteristics of a hyperbola. We'll talk about the standard forms, and then I'm going to show you how to graph one. And then I'll give you a little bit more with the graph tomorrow in class. But now I just want to get you a general idea of what hyperbolas are like. So when you draw the graph of a hyperbola, this is what they're going to look like. Like when you actually graph it on your paper, it's going to look just like this. Now the actual hyperbola is just the solid lines here, but all of these dotted lines are what we're going to use to help us graph it. So this is a horizontal one. It opens to the left and right. This is a vertical one. It opens up and down. Few points to notice on here. We do have right here in the middle, that is my center. Okay, that's the center on both of them. Here we do have our focal points. Notice that the focal points are very similar to what we did with parabolas. They're inside of where the parabolas open. So these are my focal points here, my foci. Let's go ahead and label those. Okay, these diagonal lines here, the ones going this direction, those are called asymptotes. Okay, asymptotes. Now, I don't know if you've done an asymptote before, maybe when you graph rationals, but asymptotes are lines that the graph gets very close to, but it never crosses. So we're going to use the asymptotes to actually help us draw our graph. Okay, we still have vertex points, vertices. That's here and here. Notice they're like the vertex of a parabola a little bit. So you've got your vertex points on both sides here. So I'm going to label that. That's a vertex point. All right. And to get those vertex points, that distance is still a, just like we did with the last, or what we did with ellipses. And then this distance, I'll use another color here. This distance, just like we did with ellipses, that distance is b. So you still have your a's and your b's, just like we did with ellipses, and we're going to work off of that. And then the distance out to my focal point, that's still c. Okay, so we're still going to deal with the a, b's, and c's. We're still going to have our centers, opposite h, opposite k. Very similar to what we did with the ellipse. And actually, when we go to graph it, we're going to do just what we did with the ellipse. We're going to find our center, we're going to graph the a's and the b's, and then we're going to kind of go from there to get a picture of the graph. If you'll notice, the standard forms here look very similar to what we did for an ellipse, but notice that it's a minus here. This is a minus, not a plus now. That's the major difference for a hyperbola. It's a minus, not a plus. And then also notice the a squared is always the positive denominator. Okay, now what will happen when you do hyperbolas, for the most part, the minus is always in the middle, so the negative one comes second. So a squared typically is going to be your first denominator. So notice over here under the vertical one that the y minus k became first. Okay, when we did ellipse, a squared and b squared switched, but when we do hyperbolas, the x minus h and y minus k switch. So a squared is going to be this first denominator, or it's going to be the positive denominator. All right. Now, as far as the information we're going to find, we're still going to find the center, opposite h, opposite k. That doesn't change. Our vertices, we're still going to use a, and it's the distance from the center. That's not going to change. Focal points, we're going to use the calculator to find that, but that's still going to be our c value. And then now with a hyperbola, we're going to talk about a transverse and a conjugate axis. With ellipses, we called it a major and a minor axis. They just changed the name for hyperbolas because it's a little bit different meanings. But we're still going to use a to find our transverse axis. And actually, your transverse axis is actually 2a. Okay, just mark that out there. Is 2a, and the conjugate axis is actually 2b. So we're still going to use a's and b's to find those. So it's like your major and minor axis for an ellipse. Okay. All right. So now let me give you an example, And the example I'm going to give you, we're going to do a horizontal one here, and it's going to look like this when we get done graphing it. But let me show you how to do this. It's not too bad. I'm going to show you this, and I'll give you more examples tomorrow, but at least this kind of get us going. Okay. So first example here, we've got x plus 1 squared over 9 minus y plus 2 squared over 16 equals 1. Now, I know that this is a hyperbola because that is a minus. If I change that to a plus, this becomes an ellipse. All right, so let's just start out with what we know here. Our center, opposite h, and remember h always goes with x, k always goes with y. So opposite h, opposite k. So -1, -2 is my center. Okay, and I'm going to go ahead and I'm going to put that on my graph. So -1, -2. There's the center of my graph. Now, what I'm going to do next is I'm going to figure out what a and b are, and then I'm going to use the calculator to find some of this other information. So remember that a squared is always the positive denominator, or in the positive term here, which is going to be our first one here. So if a squared is 9, that means that a is 3, and if b squared is 16, that means that b is 4. Okay? So what I'm going to do now is I'm going to go to my calculator. I'm going to go into my apps menu. All right, so we go apps. Actually, let me just quit out of there. So we go apps, go down to conics, and I'm going to go to hyperbola. Okay. Now here's what's nice. When you look at the standard forms here, notice that a squared is always the first one. So it's the standard forms that I gave you. And when we're looking at this, what's going to happen is a squared. We're looking at the first one here. We've got a horizontal hyperbola. Now I'm going to put in a is 3, b is 4, and then I'm going to put in my center, my h and k, so -1, -2. And then I'm going to hit alpha enter, like we normally do, and I'm going to come up with this information right here. Now I know some of you may not have a calculator at home, so you can just write this information down because in class you're going to use the calculator to find the information. So notice it gave me my vertices there, vertex 1 and vertex 2. So -4, -2, and 2, -2. That's my vertice points. Notice it also gave me both my focal points. So I've got -6, -2, and 4, -2. Okay. Now this slope here, I'm going to talk about that tomorrow because that deals with the asymptotes. I'm going to show you that in class. But that gives me the information there. Now, with just that information, I can actually, begin to draw my graph and look at what's going on. All right. So that gives me that. I can go ahead and figure out my transverse axis because I know that's 2a, and 2 times a is going to be 6, and my conjugate axis is 2b, so 2 times b is going to be 8. Okay. Now, let me show you how all this works when we put all this together. So my vertice points are -4, -2, so I'm going to graph that. So 1, 2, 3, 4, -4, -2, and +2, -2. Okay, and if you look at this, 1, 2, 3, 1, 2, 3. These vertices are 3 units away from my center. Well, that was my a value. So I just counted 3 this way and 3 that way for a. That was my vertices. Now, here's what I'm going to do for b. For b, just like we did with the ellipse, I'm going to count opposite. So I'm going to go vertical for b. So I'm going to go 1, 2, 3, 4 up, and 1, 2, 3, 4 down for b. So I counted a 3 units, and I really didn't need the calculator to figure this out. But I counted 3 to the left and right for a, and then I counted 4 up and down for b. And also notice for a, it's under x, so I counted horizontally for a, and b is under y, so I counted vertically for that. Now, what we're going to do from here is we're going to form a box. So what I'm going to do, I'm going to make this box here. Just like that. Okay? And then I'm going to connect the diagonals of the box, so corner to corner, and I'm going to go through the middle. And when I do that, I am creating my asymptotes. Okay? Now, if you go back up here to the top and you look, see all these dashed lines here? That's what I've just created there. Okay? Now, from that, I can draw my my hyperbola here. Now, when I'm drawing the hyperbola, I want to work off the vertices. So we're going to work off of the direction that I counted for A. Don't work off your B. We're going to work off A. Okay? And all I'm going to do is I'm going to draw parabolas using my dotted lines as a guide. So I'm going to use dotted line here. So I'm going to work right off my box. And then I'm going to come over here to this vertex. And I'm going to do the same there. And you just graphed your hyperbola. And if you look, the distance from this vertex to there, that is 6. That's my transverse axis. And the distance from here to here, which we don't call co-vertices, but it's like a co-vertice in the ellipse, that distance is 8. That's my conjugate axis. So your transverse axis actually connects your vertices. Your conjugate axis actually goes in the other direction, and that helps you with the box here. Okay, so really, in order to graph, all I really need to know is the center and the vertices, and then I can get my conjugate axis, and I can draw my box. Really, what you need is your center A and B, and you can draw the box. I am going to put the focal points on here, which you don't have to graph those, but just to show you where they would be. This would be 4, 2, and then negative 6, 2 would be there. So they are inside of my hyperbola there. Okay, we'll go over more of these tomorrow. I'll show you a little bit more about the asymptotes, but that's the basic idea of how to graph those.